And here I am. And sharing my screen and getting up the appropriate document. Seeing when I first upload it, I still don't know why. And now it does. Okay. So tonight, I'm going to familiarize myself with Cramer's rule, a long ago learned rule for solving 2x2 and 3x3 matrices. And let's see if I can remember how to do it. So, okay. So we have 14 chances to get it right. So for a 2x2 matrix, a system of two linear equations. Let's say 2x add 3y equals 7 and 5x take 11y equals 13. We can turn this into an augmented matrix just by stripping off the coefficients. As long as the x's and y's are all lined up and the constant solutions are all lined up and just everything is all neat and tidy, we can do this. 2, 3, 5, -11, a bar, and then 7, and then 13. So there's three things at play here. There's just big D, which is the determinant of this matrix right here, 2, 3, 5, -11. Then there's dx and dy. So d with a little x and d, wait, I'll do it in red, d with a little y. And here's what dx looks like. It's the determinant of this matrix, where the 2 and the 5 here, I replace them with the 7 and the 13. And the 3 and the -11 stay where they are. And for dy, it's the determinant of this little 2x2 matrix here, where the 2 and the 5 stay where they are, but it's the 3 and the -11 in the y column that get replaced with the 7 and 13. Okay, so let's just compute those. So the determinant of this matrix here, the determinant of a 2x2 matrix in general, when it looks like this, A, B, C, D, is AD, take away BC. A times D, take away B times C. So in this case, it's -22, take away 15. And -22 take away 15 is -37. Over here, 7 times -11, well, that's -77. And -77 take away 39 is -116. Over here, it's 2 times 13. Take away 7 times 5. So 26. Take away 35. So negative 9. And then, if I remember correctly, you just get the solutions by doing this. It's dx over d to get what x is. So that would mean negative 116 over negative 37. So let's check that. Yeah. And for y, it's dy over d, which is negative 9 over negative 116. In other words, 9 over 116. But we have to check. We have to check and see if I've remembered that correctly. So, how to check? Oh, don't Google. Do it yourself. But how? Using all the other techniques that you've learned, like solving by elimination and substitution and so on. So let's use the way that we know that works, which is elimination. So we're going to eliminate x times the top one by 5 times the bottom one by 2 and it's your choice. But for me personally, I'm going to do top take away bottom. So 15 minus 22 is 37. 35 minus 26 is 9. And so y is 9 over 37. Let's see if we're in agreement. Darn it. So I may have misremembered how this rule actually works, because definitely I did that right. Didn't I? Didn't I? Yes. Right, so I have to check. Let's see. Oh no, please, 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 please don't tell me I've misremembered how to find the determinant of a 2 by 2 matrix, and I'm forgetting to divide it by the fraction. No, that's actually fine. So what is going on here then? How much of a missed memory is this? Oh, wait. That should be 37 on the denominator. Oh. Okay. Error detection is good. It's intrinsically good. Okay. 9 over 37, that's y. Right. As for x, now I could sub it back in, but instead I really want to just grab the whole lot and this time just eliminate y. So to eliminate y, multiply the top by 11. Multiply the bottom by 3. add the top and the bottom together. And you can see that it's all good. So Cramer's rule was remembered correctly, and that's a good thing. And now to put it into action without making mistakes. Here we go. And I want to learn how to lay it out efficiently as and when I do it. Okay, so how to lay this out efficiently. Yeah, we'll do it like this. Determinant of the entire thing minus 2 and 20 minus 2 minus 20 minus 22. -10, -100, 10 take 100 is minus 90. Twenty take away 20 is 0. So that cannot be right. And we'll check. No, it is. It is. Okay. No. It's not. I'm just wrong here, and I need to fix it. Fix it. $110. Not 90. 110. Minus 22 over 110. So 110 over minus 22 is minus 5. So that solves it. Okay, second one without error. I believe that's correct. Yes. Right. -2, -8. Zero, -20, 2, -1, 0, +40, dy, 2, 4, 0, -20, -40, check. Good. Again. The determinant is 0, and therefore this has no solution. Because if I multiply the top by -3, then that turns into 3x 3y equals 3, which in fact means infinite solutions. Here. -10, +10. No solutions at all. Check. Good. Infinitely many solutions and no solutions at all. Lines that lie on top of each other, lines that are coincident, and lines that are perfectly parallel to each other. That's the visualization of it. Next to. No, go by column. -1, -2, 4, 5. dy. Next. Minus 80. Check. 2, 0, negative 2, 1.5. Crap. Damn it. Got the y bit wrong. How? Minus 80 minus 50. So minus 80 plus 50. So 30. 30. Ah, divided it by the wrong thing. Darn it. 3. D. Zero. And of course we recognize that same line or equation, so infinitely many solutions. Okay, we're now using A and B. Slight change. 7 minus 4 minus 1 minus 2 minus 14. Minus 14 and 4, so minus 18. Call it dA. Get the variables right. 2, 2, 0. Call it dB. Get the variables right. 7 minus 4 minus 1 minus 2. So minus 14 and 4. Minus 14, take 4. Minus 18. A is 0. B is 1. Check. Infinitely many solutions, 0, 1. Good. Determinant 1 minus 5. 1 minus 5. Minus 20. Minus 20 plus 5. Minus 15. And the determinant of R? Wrong. 70 minus 25. The determinant of S, or ds. $100, take 70, 30. Now solve and solve Good. Next. Six, 9, 6 take 9. Wrong. $30 plus 24, 54, dy, 1 minus 3, 5, 8, 15 is 23. Okay, strange ones. Did you do it right? 1 minus 3, 5, 5, 8. Okay, so 8. 8 and minus 15, 8 plus 15, so 23. Believe it's 23. 54 over negative 3 is negative 18. And y is 23 over negative 3. So just write that. Could be, could not be. True. Last one. -31. -12. +2. -10. -12 plus 10 is -2. So A is -10 over 31, and B is -2 over 31. Here, determinant 2, 4, -3, 3, 6, plus 12, 18. Determinant of A, -8, -34, -3, 3, -24, and then 102. Believe. -68 plus 32. -126 over 18. -14 over 2, so -7. -36 over 18, so -2. And check. Correct. Okay, good. Okay. All right, so now Cramer's rule as applied to a system of 3 equations. So how would that work? How would that work? We're about to see. Wow. Okay, so we saw that for a system of 2 equations, in X and Y, say. It was D. It was this. Whoops, beg your pardon. Over D. Right. And for a 3 by 3, it's just that, but with Z. Oh, for goodness sake. There's 16 chances to get it right. Okay. Now, how do you do the determinant of a 3 by 3 matrix? You know what? There must be a way to open up this application twice. There is. That's glorious. Okay, so for a 3 by 3 matrix, the determinant is something like this. Take plus. Right? So we check. And we've indeed remembered it correct. Okay. Time to see if you can do it. Oh my goodness me, this is gonna just get on with it. Just get on with it. Okay. There must be an efficient way to lay this out. Can't possibly do that in there. Minus 2 times. Okay, determinant of that. 24. No! Wrong. Come on, try again. That's 20. That's negative 4, so it's going to be 20 plus 4, so 24. And this is going to be plus 5, and this is going to be minus 4. 20. Minus 48 plus 20, so minus 28. I think that's the determinant of that. We'll see. We're going to have to check, of course. 21, and 8. and just copy and paste from here. Scratch pad, 21 and 5 and 4. See, it's already an error. Okay, I can see it, but it's better that I spot the errors, isn't it? So this is 180. 180 take away 48 is 132. Minus 84, minus 8, so minus 92. And put them together. Come on. $454, isn't it? Take 460. Take 176, which is so like minus 6, so like minus 182. And goodness me, that's just for one? Yeah. What's the issue? I thought you know how to do this stuff. So do it. 21, 21, 8. Minus 2, minus 21, and 4. And here, minus 84, minus 8, minus 92. Put them together. So minus 580. So just minus sign. There. Come on. Mm. Okay, so apparently x is going to be negative 182 over 132 which is negative 91 over 66. Now that's as far as I can go. There's no way this is right. There's just no way. Still though, just don't worry about it, just try. Okay, so y is negative 396 over 132 half half again. Oh, okay. Oh, okay, that's good. So y is appreciable, and z is this, which becomes this, which becomes, no, it doesn't, wrong. That's 14 times 11. 14 times 11. So cancel that out, please. Okay. What on earth are you talking about? 14 times 11 and 6 times 11. So 14 on the top, 6 on the bottom. So 7 on the top, 3 on the bottom. There you go. No way this is right. But check. Yep. Man. Oh, man. Cramer's rule for 3 by 3. That's absolutely unbelievable. I don't even think that this is intended for human purposes. Maybe on a different day. Really? There's just no way, man. Each of these is going to take me 5 minutes minimum. Just absolutely insane. I don't think it's practical. I don't think solving 3 by 3 equations by hand is practical in the first place, but perhaps on another day. Perhaps on another day. We have to think about it. All right. So we're going to do matrix equations. Okay. And it would be advisable to delete that until we're fully ready or think that it's actually within our grasp. There must be I would say overall, I'm pretty okay at arithmetic. I don't get everything right. I used to be fantastic, but it requires constant maintenance. But maybe students really are that good, and I'm so out of touch. We'll see. Okay, so matrix equations not requiring inverses, and how many are there to do? Well, there's 20, so we better get started. Okay, so B has to be a column matrix, and it has to be a fifth of this. So -1, 1, -4. A has to be a column matrix, and it has to be that column matrix on the right, take away that column matrix there on the left. In other words, what do I have to add to -9 in order to get -6? And the answer is 3. And the answer here is -3, and the answer here is 7. Check them. Okay, we're in agreement so far. What minus 5 is 4? So what plus 5 is 4, and the answer is -1. What minus 11 is 3, so what plus 11 is 3, and the answer is -8. A scalar of 5 multiplied by a 2 by 1 column matrix B. It's pretty obvious. Whenever you say the O word or the E word, obvious and easy, you get it wrong. Anyway. Check. Okay, an agreement. Okay, so now eight minus 8 is 0, so 0 minus 8 plus 11 is 3, so 1. Minus 8. 31 plus 5 is 36, divided by 4 is 9. 32 is 32, 8. Good. Negative a third of what's 10 plus negative 25? Well, that's negative 15. What's 0 plus negative 30? Well, it's negative 30. What's negative 25 plus negative 22 plus negative 5? That's negative 27. Make it clear what you're doing. There. (17) minus 3 is 17 plus 3. No, wrong. Negative 17 minus 3 is negative 17 plus 3, which is minus 14. Negative 11 minus 11 is minus 20. Negative 30 minus 8 is negative 30 plus 8, which is negative 22. Negative 12 minus 6 is negative 12 plus 6, which is minus 6. And compute. 10, 11, 3. And check. 7th, 301, correct. That's fine. That's fine. That's fine. All right. Next up. Negative a half, and then add that to that. So 4, 14, 0. There. Negative a half of that to added to that. Which is declare what's what. Yes? You've done that. Okay, fine. Negative 7, 6. Okay. Next. C is a quarter of that 2 by 3 matrix there, added to that 2 by 3 matrix there. So it's 16. That's negative a quarter of that 3 by 2 matrix there, added to that 3 by 2 matrix there. So that's 28. And when we negate and quarter it, Now check these four. That's correct. That's correct. That's correct. And that's correct. Next. All right. So B is negative a quarter of that column matrix on the left added to that column matrix there on the right. So just add them together. And quarter them and negate them. There. Okay, X is a quarter of the matrix on the left, take away the matrix on the right. Negative 20 minus 8 is negative 20 plus 8, which is negative 12. 33 minus 1 is 32. 15 minus 7 is 8. Minus 15 minus 1 is minus 14. And now quarter it. Negative 3, 8, 2, and negative 7 over 2. And check. 707 is right. That entry there is wrong. I knew that that was wrong, but why? Because negative 15 take 1 is negative 16. Darn it. Okay. Quarter it. There. All right. Now to continue. Okay, just 4 more. I'm going to do it. Okay, so A is negative a half of the matrix on the left plus the matrix on the right. So that would be 16, 6, 4, and negative 14. And now half it and negate it. So negative 8, negative 3, negative 2, and 7. Okay, C is negative a quarter of the matrix on the left plus the matrix on the right. So 20, 0, 32, 0, and quarter it and negate it. So negative 5, negative 8, and 0, 0 in those spots right there. And check. Valid. Okay. Add m to both sides, so we get 3m on the left, and then m will end up being 1/3 of the matrix that we can see on the left and the matrix that we can see on the right. That one on the left, no, the one on the right, take away the one on the left. Okay. So negative 6, take away 5, negative 11. 2, take away 4, negative 2. 0, 4, take away 8, negative 4. You sure about that? Yeah, I'm sure. And here, okay, just swap them around. One, 8, take away this. And when we take them away, we have 7, 2, 5, and that's m over 4, and now quadruple. 28, 8, 20, and check. Okay, good. No disagreement on the last one, but why? Because it's -8 and I copied incorrectly, that's why. So -8 minus 3 is -11. Error detection is good. It just is. 44. -44, come on. Don't be sloppy. All right. Okay, I'm satisfied with that. And now to consider where to go next. So that was the easy version. Supposedly. And that was checked as well. And now the harder one. Do it. Download it and do it. Okay, here it is. And here it will be done. But just prior to that, hydrate. Check. Okay. Okay, so inverses are required. So I need to be able to invert a 2x2 matrix. Now, for inverting a 2x2 matrix, so if I remember correctly, you swap the entry. No, it's 1 over the determinant of it, and then you swap the entries, the diagonal entries, and negate the off-diagonal entries. That may be right, that may not be right. I must check. So, no, wait, I know that 1 over the determinant of the matrix makes sense, because if it's 0, then it's non-invertible. Okay, that's fine. So, we'll do a matrix that you know the inverse of. So I know the inverse of the identity matrix. The determinant has this. And this is called I2. The determinant of I2, when you apply AD take away BC, is obviously just 1. And 1 over 1 is 1. And then you're swapping the diagonals. That's there. And negate the off diagonals. Okay, because if I were to multiply 1, 0, 0, 1 by -1, 0, 0, -1, like in other words, it by its negative, well, I don't know what would happen. I need to investigate. And to be sure, I suspect it will just be this guy. So That's correct. Okay, so just do it. So to get x, multiply on the left by the inverse of this matrix right here. How about that? Okay, so to invert that matrix, first find its determinant. And the determinant is 8. Take away 14, which is minus 6. So it's 1 over minus, so it's negative a sixth. And then do that funny thing, which is like, come on, why do I keep forgetting? Okay, swap them and negate these. There we go. And now do that there like that, because that's what we're going to do anyway. So multiply the matrices first. Are you sure? Yes, I'm sure. Right, negative a sixth. So we have negative 12 and 24. Put them together and we get 12. Then we have negative 42 and 48. And put them together and you get 6. And now the scalar multiplication here. Minus 2, minus 1. So that seems very lovely. But I must check. Oh, yay! It's actually correct. Okay, I'm going to keep going. That motivates me. But, you know, I can use this space here, can't I? Okay, so invert that matrix there. Find its determinant. There must be like a quicker way of writing this. Whatever. Just find its determinant. Two. Take 5, isn't it? So minus 3. So it would be minus 1 over 3. And then swap the main diagonal. Negate the off diagonal. And you're good. And put 4, negative 26 there. And now times them out. So negative 8 plus 26 is 18. Negative 20 plus 26 is 6. And negative a third of that is negative 3, negative 2. And check. Oh, damn it. Oh, foolish finish line tripping there. Good. Okay. Try again. Get it correct. Okay, Z is the determinant 1 over the determinant of this. So 10. Take 15, which is minus 5. So minus 1 over 5. Swap the main diagonal. Negate the off diagonal. Stick that matrix there. So negative a fifth. Negative 5 and 60 is 55. Negative 5 and 40 is 35. And negative a fifth of this is negative 11, negative 7. Next, determinant 0. Okay, so it's 9. So 1 over 9. And now that. And next this. And next this, which is this. And check. And correct. And it's all good. Okay. Determinant. Negative 10 minus 12. So negative 10 plus 12. So 2. So 1 over 2. Swap. Negate. Matrix multiply. $60 take 44 is 16. 36 take 44 is minus 8. And scalar multiply. So 8 minus 4. And here, 3x is this 2 by 2 matrix here. So multiply both sides by 1/3. So x is 4, negative 4, 7, negative 9, and check. Oh man. Okay. We got the top right. That's right, but this is wrong. Find out why it's wrong. Okay, so I do not know. Wait. 36 minus 44. Come on. So minus 10 minus 12 is minus 10 plus 12, which is 2. And so half is the correct thing. Swap things on the diagonal. Negate the off diagonal. I know that it's something like I just do not know. Why can I not see it? 36 minus 22. 36 minus 22. Oh, yes, that's it. That's it. 36 minus 22, which is 14. And half of 14 is 7. So that's it. Okay. Good. All good. Okay, so that is x, so I need that to turn. Basically, I need to left multiply by the inverse of this. So x is the determinant of this. So what's the determinant of that? Negative 14 minus 6, so negative 14 plus 6, so negative 8. So negative 1 over 8. And then swap the main diagonal, negate the off diagonal, pre-multiply, and carry this out. Negative 50 plus 26 is negative 24. Negative 26 plus 18 is negative 8. Negative 75 plus 91 is 16. Negative 39 plus 63 is 24. And then by negative an eighth. So I say 3, 1, negative 2, negative 3. Same thing, similar thing here. The determinant of that matrix, 24 minus 25, so minus 1. So I love it when it's minus 1, because the arithmetic. That is what x is equal to, I believe. And now multiply and negate the entries. Best just multiply first and negate after. Yeah? So negative 80 plus 75 is negative 15. No. See? Negative 80 plus 75 is negative 5. 12 take 15 is minus 3. 100 take 90 is 10. Negative 15 plus 18 is 3. And so all negatives now, 5, 3. And check. All correct. Good. Okay, solve each equation or state if there is no unique solution. No problem. The right column matrix plus the left column matrix. So negative 6 plus negative 1 is negative 7. 6 plus negative 5 is 1. Negative 16 plus 8 is negative 8. And 0 plus 8 is 8. Oh boy. All right. Just do it. Determinant 0. Or 0 minus 8, which is minus 8. And so minus an eighth, of, swap them, negate them, and matrix multiply. Negative 40, negative 40, negative 48 plus 40 is negative 8. 24 plus 40, 64, Zulane, and 5, and 5, and 1, and minus 8. Now check. Correct. And all good. And now what? The determinant of this, because one of the left columns is just a bunch of zeros, it will be 0. And therefore, this has no inverse. And therefore, there are no solutions. As matrix X is non-invertible. Okay. What's the determinant of this? 18, 21. So that'd be 18 take 21, which is minus 3. So minus 1/3 of swap on the main diagonal, negate on the off diagonal. Put that matrix right there. And matrix multiply. Matrix multiply. So we get 81 take 63, which is 18. Negative 100 and 135, negative 135, plus 117. So like negative 18. Okay. 63. Take 42. 21. Negative 105. Plus 78. Negative 105 plus 78 is negative 27. And now negative 1/3 of this. So negative 6, positive 6, negative 7, positive 9. And check. And it's good, and it's all good. Okay, so the inverse of this matrix over here . So we have negative 9 and negative 4. So negative 9 plus 4, which is negative 5. So negative 1/5. Swap the main diagonal. Negate the off diagonal. and multiply. Okay, so -27 plus 42 is 15. I'm not stopping. -45 is this one. -117 take 72. Well, that would be 45. 6 take 21. That's -15. 10 is just 10, my favorite number. And -26 plus 36 is also 10. Very pleasant for me. So here we go. -3, 9, -5, 3, -2, and -2. And now this one. C is determinant of this, please. Well, that would be 1. Take away nothing. So in other words, 1. It's all 1. Okay. It's all 1. How philosophical. Anyway, swap. And negate. Careful. Nearly slipped there. And 11 and 2. And multiply out. So -11 plus 18. Well, that's 7. And that's -2. And check. Just one entry. One entry is wrong. Find out why. Oh my goodness. Are you kidding me? They were right next door to each other. But I found it, and that's the main thing. Assuming that a solution exists, what are the dimensions of M? So recall, well, how do I say this? An M by N matrix can only be multiplied by an N by P matrix. These are like dimensions, so like number of rows by number of columns, number of rows by number of columns. So the columns of the first matrix have to match the rows of the second matrix. And anyway, and what it results in is an M by P matrix. Right? And to just very quickly check that, because you never want to, you can always just quickly check things with like little tiny creations. Okay, so like do a 1 by 2 matrix, and then multiply by a 1 by 1, 2 by 1 matrix, and we do indeed get a 1 by 1. So you know, yeah, it's right. Okay, so thing on the left is 3 by 2. M, we don't know. Thing on the right is 3 by 2. So what has to go here? Well, it has to be 2. What has to go there? Well, it has to be 2. So M is a 2 by 2. 2 by 2 matrix. Next, find one solution to this. So I have a feeling this is sort of like some kind of trick business. So I'm curious. I need to learn these patterns of matrices better to really start getting a feel for what matrix multiplication is, and not just these sort of algorithmic level procedural. So when I do this, I get C and D, and then nothing and nothing. Okay, well, based on that, X must be 3, 5 on the bottom and 0, 0 on the top. And now we check. Oh, yes. 3, 5 on the bottom, but it can be anything on the top. Can't it? Yes, it can. Okay, that's good. That's good. So all done. So now to check how things are going. Okay, just did that one. All right, and now to brush my teeth, and I'll be right back. Be well. Be well.